let's have a look at this first example. This is in your booklet. This is example number 12. Example number 12 asks us two questions, and the first one has a few parts. Now, the first part, A. Show by substitution that x is equal to 5 is a 0 of p of x. Okay, so if it's a 0, what do we know? If it's a 0, then that means if we substitute that value for x in, it should give me 0. That's what it means for it to be 0. So let's do that. AI. So I want to do p of 5. So I'm going to substitute, wherever I see x, I'm going to substitute 5. So p of 5 is going to be equal to 3 times 5 squared minus 30 times 5 plus 75. Okay. I think this does in fact give me 0. This first term is going to give me 75. That's going to give me 150. This is 75. And when we do that, we get 0. So therefore, 5 is a root / 0. Okay, so that first part hopefully was quite simple. All we needed to do was substitute x is equal to 5 into our polynomial. The next part, you want to use the sum of zeros to find the other 0. Now, this is what we do when we're using the sum of zeros. Now, if we have a look up above, if you recall from up above, what we said was, we have our two relationships. We've got the sum of zeros, or the sum of roots, as it's sometimes also called, and we've got the sum of product of zeros, or the product of roots. What they tell me is that they have a special relationship with the coefficients of my polynomial or my quadratic here. So let's just recall, so sum of roots tells me, if I've got my two roots, alpha plus beta, that will be equal to negative b over a. So I've got my two roots, and when I add the two roots together, they're going to give me negative b over a. Now just remember, b is your coefficient of the x term, and a is your coefficient of your x squared term. So let's have a go at putting this in. So I know from here that one of my roots is actually a 5. So let's just say, okay, we'll let beta be equal to 5. We know that one of my roots or my zeros is 5. Let's have a look at the polynomial I'm working with. I've got 3x squared minus 30x plus 75. So let's just have a look at this polynomial up here. What are the values of a, b, and c? That's the first thing I need to kind of establish when I'm looking at these types of questions. Okay, well, a was just a coefficient of my x squared term. So let's have a look here. A will just be the 3 here. A is just a coefficient of my x squared term. Then let's have a look for b. B is my coefficient of my x term. So let's have a look. B is going to be negative 30. B is going to be negative 30. And the final part is c. So c is just a constant term. Here, c is equal to 75. So we're going to use all three of these parts to help me answer these next two questions. Okay, so the first part is sum of roots. It tells me that alpha plus beta, so the sum of my two roots gives me negative b over a. So I don't know what one of the roots are, but I know that the one is 5. So I've got alpha plus 5 on one side. So I know that one of my roots is 5, so I'm going to let beta be equal to 5. And I know that is equal to negative b over a. Well, what was our values for b and a? Let me scroll back up. I know that b is just negative 30, and I know a is just 3. So I'm going to put those two values in. So I'm going to have negative 30 over 3. Now when I simplify this, I'm just going to get negative 10 in the fraction. But because I've got a negative at the front as well, that's just going to turn it into a positive 10. So here, what I'm going to have is alpha plus 5 equal to 10. Okay, cool. Now if I'm just I want to find that other root. So I know that alpha is going to equal to, well, 10 minus 5, which will give me 5. So alpha is just 5. Now here, this has this very special name, and we're going to actually look at this a little bit later when we graph our polynomials. But if you notice, both of our roots are 5. Because both of our roots are 5, we call this a multiple root. Because both our roots are 5, we call it a multiple root. In this case, it's a double root. Because how many times does 5 appear That's right. 5 appears twice. Man, I feel like I'm running Dora the Explorer right now. Okay. C. Okay, so that's part 2. We use the sum of roots to help us find the other root in our polynomial. Part 3 wants us to use the product of roots to find the other zero. Now, what we should get is essentially the same answer, but we just want to do it in a different way. So let's just use the product of roots for this time. So product of roots. Now, if you remember, the product of roots tells me, and if my computer decides to zoom, there we go. The product of root tells me that alpha times beta gives me C over A. This is positive C over A. So all I need to do is I just need to substitute my values in for C and A, and also for my beta, because I already know what one of the roots are, and that should be okay. And then I should be able to find the other root. Okay, so let's have a look back up top so I can have a look at my values. So I know from here, I know that my alpha A value is 3. I know my C value is 75. So all I need to do is substitute them in where I see C and A. So let's have a look here. So I've got alpha and beta. I know that one of my roots beta is equal to 5. So I'm just going to write 5 alpha. Now, when you're doing this, don't write it like that. It's just a little bit messy. If I can erase it. Nope, I erased too much. I've got 5 alpha here, and that's just equal to, well, C was 75 over A was 3. So here, I'm just going to divide 75 by 3, and that'll give me 25. So I've got 5 times alpha is equal to 25. So my final alpha result should be 5. And that's exactly the same as the thing that we got up above. So that's it. That's how we use the sum and products of roots. That's for the question, example 12, part A. I'm going to have a go at part B as well. So here, we've got this question here. We want to find the sum of the zeros of this polynomial Q of x is equal to x squared plus 7x plus minus 11. And we want to find the sum of the roots. Okay, so let me just write down I scrolled down a bit too far. So what I'm going to do is I'm going to just write my polynomial. So I've got, this time it's Q of x is equal to squared plus 7x minus 7. I want to find my sum of roots. I want to find alpha plus beta. Now, if you remember, alpha plus beta is equal to negative b over a. Negative b over a. So if you have a look, let's just label the parts in my equation here. So what is the value for a, b, and c? If you're trying to do a question on this in an exam or in your books, what I recommend is just off the side. So usually what I like to do is, even before I start the question, off the side, I'll just go, okay, it all erases. No, it doesn't. Shame. Oh, there we go. I'm just going to write on the side, A is equal to, C is equal to, B is equal to. Okay, so I'm just going to label the parts of my question. So what is the value of A? A is just the coefficient of x squared. If you have a look here, there's no number, so that tells us what's the coefficient? Exactly right, the coefficient is 1. So we've got a coefficient of 1 here. Okay, what is the coefficient of B? The coefficient of the coefficient B is just the coefficient of my x term. So here this is just going to be a positive 7, and C is just going to be my constant term, which is minus 11. Okay, so when I'm trying to find the sum of roots, what I'm going to do is I'm going to sub in B and A. So here, alpha plus beta is going to equal to negative. B is 7, A is 1. I'm just going to divide the 2. Okay, so alpha plus beta is equal to negative 7 over 1. So alpha plus beta, I'm just going to write this a little bit nicer, is equal to negative 7. Now, the second part is to find the axis of symmetry for this polynomial. Now, in advance, we had a look at the axis of symmetry by finding the two zeros or the two x-intercepts and finding the midpoint. So kind of averaging the two so we can find the midpoint between the two. And then we could find the axis of symmetry, the x value that is right in between right in the middle, the mirror line for my quadratic. Now here, you might not be immediately obvious how we do that. But what if I told you that alpha and beta, they're our roots. Alpha and beta are roots. Alpha and beta are roots. the roots are the equivalent. If we were to graph our polynomial, our roots are the same as the x-intercepts. The roots are just our x-intercepts. So if we were wanting to find the axis of symmetry, so let me just recall when we were trying to find the axis of symmetry in advance, what did we do? Well, we add the x-intercepts and then we divide by 2. So if we know that the alpha and beta are the roots, then all we need to do is we go, okay, alpha plus beta divided by 2. Hey, isn't that nifty? We already have alpha and beta, alpha plus beta. If you have a look up here, we've got alpha plus beta is equal to -7. So if we just want to find the axis of symmetry, all we do is we take that -7 and divide it by 2. There we go. Nicely done. And we are done with this question. So here we can actually use the sums of our zeros to find us the axis of symmetry. You often don't see this type of question, but it's a nice nifty trick that you can use as well. Okay, so that was our first example. That was example 12 from your notes. I've just gone through it here